Hello everyone. Uh, I don't see anyone has joined, so let's wait for some time. Hi Rohit.
Hello.
I suppose we can start because was pinged by Sarangs separately. I don't think he will be in a position to join today. So let's start. So until yesterday, I hope you have seen the things onto the LMS as well. I've just uploaded it there. Any luck with your data analysis pack thing? I mean, were you able to install?
No, actually, the thing is that I have ordered a new laptop. My old
Okay.
one has crashed.
Huh.
So I was waiting for that new one and I will installing that. Because this old laptop is of my father's and it is of year 2008 and 9.
Uh-huh.
So it's already very slow. I don't want to install anything in that.
Hmm.
It is hardly able to run an Anaconda 2. It
Hmm.
gets stuck in that. Yeah.
Okay. 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 No problem. So let's continue. Let me just do one thing. Let me share my screen, and we are going to, let's say, maybe we'll start with something very simple today, and then we will look into the other area. So until this point in time, what we have done is that we have looked into the basics of statistics and the probability. We have looked into the basics of statistical inference. As much as possible, whatever information that I've shared is only the basics. Okay, so this is not to say that whatever I've shared has no use, but whatever I've shared are is actually very basic things. Okay, because that's all we need to know to have a start. Then when we give it a start and then we try to do things, when we try to do activities, then we'll see the need of more and more things, and then we can study as more as we want. But these things that we have covered, especially when we have covered the statistical inference part, is what is going to become the baseline, or basis that baseline only we can do whatever we want to do. Okay, and that's the point here. So that is the reason why what I'm going to do is, if I go back to my class curriculum, so other than this SQL part, I believe almost all of the rest of the things are already covered, but this part is also not entirely covered. So we have only covered the tools like Excel and the Anaconda tool. Anaconda tool we will be using every time. We have not really looked into K9 or Vika. So maybe at a later stage I'll give you a quick overview. We have already done the statistical methods for the decision making, and the case of advanced statistics, what I'm going to do is, we have done analysis of variance. Before we do dimension reduction techniques, we are going to look into the regression analysis first of all, and then we can move ahead. Okay, now regression analysis is also part of something which you see over here. Okay, so as part of predictive modeling, also you see something known as linear regression. So this regression analysis and this regression thing is actually the same. Okay, but they are sometimes considered as part of the machine learning area, but they actually are not, and I will explain you why they are not, or why I would not like to classify them as part of the machine learning area. Okay, then we need to look into some basic mathematics. We are going to look into that, so don't worry. So we will look into these once we go along with the regression and the rest of the things, right? So technically we are starting with the predictive analytics part as of today, and then we will take some pause in between after, let's say, we have done advanced statistics kind of things, because I'm still figuring out how to create a lab environment so that we can practice MySQL. That's something that I need to create for myself so that I can show you the demo. So that's something that I'm still doing. I might be using some kind of cloud platform, and I'll also show you how to create your own environment in any cloud platform. So that should not be a problem. But we will do that SQL part once we have looked into the fundamentals of the predictive modeling, or maybe at least after we have looked into the regression part of things. Okay. Now, let me go back to my notepad, and what I would like to do here is that I would like to first of all explain what is the problem statement, or what is it that we are trying to do over here. So first of all, what we are going to do is actually a problem, and it is a statistical a problem itself. It is an inference kind of problem. Okay, we're trying to infer something. Okay, but it is not really a machine learning problem. At later stage, when you look at the definition of, let's say, machine learning, you will come to know why I am saying that this is not a machine learning problem. Because machine learning, on an overall level, if you look at it, it usually involves some steps. Okay, so it involves a few steps that you take to do the machine learning activities. Okay, and those steps can be clearly divided into three areas, as we are going to see later on. One is known as representation, one is known as evaluation, and the third is known as optimization. Okay, now, yes, part of the regression analysis, we are going to do evaluation. We may well be doing optimization as well, but we are really not going to do any representation. So this kind of a technicality is only going to confuse you right now. So let's get back to what we were doing, but let's not try to consider regression analysis as part of machine learning. You can call it predictive analytics, or it is still better to be classified or grouped under the statistical inference itself. Okay. Now, what we are trying to do in case of a regression problem is that, let me set the background and then we'll come to the basics as to what is a regression problem. So we have already seen the different varieties of variables that we can have, right? We can have continuous and categorical kind of the variables. Now, let's say we are in a position whereby we are in a new city, okay, and this is like, let's say, the problem that I have is every time I will have to change the city, because I am actually living, or I'm actually doing a job which is like uh, a city changing kind of a job, or the kind of a transferable job, right? So I will be having transfers from one place to another. Now this has led to a very important question of mine, is that wherever I am going to go, obviously this may not be applied on the first place where I'm going, because at that time I'm a fresher and I'm given the first initial place to join. I'll have to join anyway, so I may not have any background of that first place. But when I'm really settled there, I can do this kind of an exercise. And the exercise that I'm actually talking about is, as, let's say, I would like to know what is the size, okay, usually, okay, what is the size in square feet of the houses which are available in that new city where I'm going to get transferred, as opposed to what is going to be the rent. Okay, so rent I'm going to calculate in terms of, let's say, rupees, and the size I'm going to take in form of, let's say, square feet. Why I'm trying to do this is because I'm trying to somehow create a relationship between size and the rent. Okay, so I would like to know, in the city that I'm actually going, what kind of a sized apartment is going to cost me how much. And if I know at least approximately how much it is going to cost me, okay, then I can plan my finances in a better way. I really will not be in a position to avoid my transfer. Okay, I cannot say that I am not going to go to that place, but at least I can plan better. Okay, so what my intention is here, okay, is to find if there is a correlation between the size of the apartment I may rent versus the rent amount that I need to pay. Okay, so this is what I'm trying to find out. Okay, so for this, maybe I've done some kind of a random survey. I can do a lot of things, by the way. So let's say my approach is something like this. Let's say my approach is something like I've done some kind of a random survey, or I have went on to websites like 99acres.com. Okay, or maybe I have gone to magicbricks.com. Right. So these are websites we already know. So I've got some kind of a data from these websites. I've downloaded some data for city C1. Okay. I've already downloaded some data for the city C1 where this is the different places I have recorded the size of the house and I have recorded the average rent which is there in the house, in that house. Okay. So I could have done this in two different ways, and this is very important to understand how I can actually do something in this case. At the first place, I can, let's say there are, I don't know, in that city C1, there are, let's say in C1, we have 100 localities. Okay, obviously, I may not have the time to go through each and every locality. So what instead I do is that I pick up some random localities. Okay, so this is like the random sampling that I've done. Then I have taken the size and rent combo for these localities, right? The ones that I have picked. Okay. Then let's say I have stored them into a CSV file or Excel, right? So now that I have got the data, I would like to know if there is any relationship so that my final expectation, can I predict the rent I am going to pay? Now, this is kind of a problem statement will come a lot. We will really come across this kind of a problem statement a lot. And I would like to tell you why this problem statement is wrong. This is my background. This was my intention. And what I'm doing here is absolutely wrong. Okay. And I will tell you why that is wrong. Okay. Why this is wrong is because, let me just delete these two lines. Why this is wrong is because I can have, let's say, I can try and write down this. Let's say I have 5 friends. Okay, so I have friend 1, friend 2, friend 3, friend 4, friend 5. Out of these 5 friends, I see this friend 3 is always paying for all the parties. So clearly, he is spending good amount of money. So his hands are quite free when he is doing the uh, expenses. So this guy spends a lot. Okay, so all of a sudden, I would like to ask this person, what is exactly your salary? How much do you get? How much are you really getting paid for that you are paying for all of the parties that we are having? Now that person, let's say, okay, this person F3 has a salary of, let's say, 11.65 lakhs, okay, per annum, okay, INR. So this is INR, 11.65 lakhs per annum. Let's say he is working in, let's say, Mumbai. Okay. Now he has given me some answer. Yes, obviously he has given me some answer because he is my friend. Now, is this the only way in which this answer can be represented? The answer is no. If you look at this value, I can interpret or represent this value in multiple different ways. Okay, first of all, I can represent this as 12 lakh per annum. Right? Why? Because if I take a round figure of 11.65, obviously it's going to come up as 12. I can write this as 11.6489 lakh per annum. So in this case, what I've done is this 11.65 value was actually an approximation that I found out after some casual talks with my friend, while his actual salary was something like this. I could have also represented it in something like this, right? You see the problem here? The problem here is I can have any value. Okay, why? Because his salary is a continuous variable, right? It is a continuous value, it is a continuous data, and it can take any value. So salary being a continuous variable can take any value between, right, between minus infinity and plus infinity. This is a serious problem. Why? Because I will never be able to quantify the actual salary that he gets. So my friend F3, okay, whatever actual salary he is really getting can never be quantified. This is my issue. Okay, and this is the reason why. Okay, this is the only reason why I can actually never do any prediction in this case. Okay, this is the reason why this thing that I was actually talking about here, this predict word, okay, this predict word is wrong. Okay, this is a very big kind of a requirement that we have set for ourselves, that we have got some data here that we have collected like this. Okay, we have downloaded it from, these are the sources from where I have downloaded. Okay, later on when we actually do some practicals, right, I'll also tell you how to actually do exploratory data analysis in a very broad way, because what we have done earlier using pandas as number is like scratching the surface, so we have not really gone into in depth. But when we actually do this kind of an analysis, you have to remember that we have to start from identification of the question, which is this is my question. This question will later be converted into a hypothesis. Okay, so here also you're going to have a null hypothesis and you're going to have an alternate hypothesis. Okay, so clearly we are going to define a null hypothesis and an alternate hypothesis. We are going to look at the data sources. Then using the data sources, we are going to do the downloads. This is also known as data collection or web scraping. Okay, web scraping being one of the methods by which you do data download or a data collection. There are multitude of different ways. SQL is the most prominent way in which you do data collection in the industry. So whenever we are working, let's say in an organization like the ones in which we both are working, right? So in that case, SQL and Excel becomes one of the primary sources from where we get the data, because multitude of the databases, 80-25% of the databases will find uses some form of ANSI SQL. Okay, it can be represented, its value, its data can be accessed by some form of ANSI SQL, and having a knowledge of SQL is extremely important. Okay, it is not to be taken lightly. Okay, I can be a PhD in Python or R or into machine learning and deep learning and reinforcement learning and all these names, but if I don't know SQL, it is going to be a big problem for me, because then I won't be able to sample my data. I won't be able to collect my data. My data engineering pipeline, which we are going to later look at, is going to be in stake, right? So now that we have known that we are going to have a question, we define the hypothesis, then we collect the data, we identify the sources from where we are going to collect the data. Ultimately, we collect the data, we download that data, we store that data in some way. So this is where we are going to store that data. Storage comes into play. We may want to automate this entire process, right? Because let's say I have taken this data today's what, 17th of July, right? I've taken this data on 17th of July 2020. 17th of July 2020, in any city, any state I might belong to in the entire world, I'm either part of a lockdown or I may not really be part of a lockdown, but I know that I'm part of a pandemic. And that's the reason why we all know, and we can really expect this, that irrespective of the size of the apartment that we're looking for, the rent or the rents of such kind of apartments have already gone down, right? The home market or the builders market is not really very good right now. Okay, the real estate is not really doing very good. Okay, why? Because there are a lot of job cuts. People are, I mean, they can't go out, right? So people, in the between this pandemic, there has been a huge impact on the housing side of things. So that is the reason why I know that as of now the average will be less than the moderate value that I can expect. But what happens in 2022? right? This pandemic is not going to continue by that year, right? Within the next 1.5 year at a max, this pandemic will be resolved. So by 17th of July 2022, we will have to again collect the data. Okay, this is just an example, by the way, but in the industry you will find that every day you need to collect new data because your transactions are changing, your customers are changing, scenarios are changing, and so on. So that's why you have a problem statement, you have defined the hypothesis. Now ideal condition, what you will do, you will try to automate this approach. Okay, you would like to automate the approach, and this is known as your data science or data engineering pipeline, or it can also be called a machine learning pipeline if we are at all going to do machine learning. In this case we are not doing, right? So we are not going to predict anything, we are not doing any machine learning here, we are simply doing regression analysis. It is just a way of doing statistical inference. So that's the reason why we are not going to do any prediction, we are going to do inferences. Okay, how do we do the inferences? We are going to do an activity known as approximation. Okay, this is one of the most important activities when it comes in the life of a data scientist, because there are a couple of more things which are also equally important as approximation. The other thing is optimization. I don't think in the curriculum I have written that as one of the points that we would like to cover, but optimization is really going to come handy, and we are going to look into the optimization techniques as well, right? So but approximation clearly divided into two kinds of approximations that we can do using continuous data. One is known as interpolated approximation. We will look into the definitions, okay, don't worry, but just to give you an overview, approximation can be of two types. It can be interpolated approximation or extrapolated approximation. Okay, now what we are looking at over here, regression analysis, is an interpolation or interpolated approximation. I will define why this is the case at a later stage, but approximation is what we are going to do. So we are just going to approximate the salary that one person like F3 can have if, let's say, I come to know what is his experience in IT industry. Okay, this is the most common example we take whenever we are trying to predict or whenever we are trying to guess the salary of any employee. Just like ourselves who are working in the IT industry, we would like to know what kind of experience that person has. So that's the first quick question we ask. How many number of years of experience do you have? Oh, you have 7 years of experience and you're getting a salary of 11.65. It might make sense because that's kind of a thing. I have also seen my friends getting a salary like this. So this is kind of an approximation that we are doing. Okay, because basis the number of experience in IT industry, which in this case, let's say, is equal to 7 years, I approximate you might be getting a salary of 12 lakhs per annum. Okay, so you are simply approximating, you are not evaluating. Okay, that is the reason why this cannot be called a prediction problem. Prediction problem is where you actually predict some value. Here you cannot predict that value because that value itself, as I said, is going to take any value between minus infinity and plus infinity. What are you going to predict? Every time the prediction is going to be wrong, right? You cannot really predict anything because the whatever value you are going to predict of this friend's salary or the rent that you need to pay given the size of a house, it's always going to be wrong. It's always going to be wrong because that value falls between minus infinity to plus infinity. So what we are essentially going to do is that we will take the data, and let me change the color as well. We will take the data, we will draw a graph like this, and we are going to draw the point. So what we are going to do, on the x-axis, let's say, we are going to take the size of the house. On the y-axis, we are going to take the rent of the house, and we are going to plot the values that we have seen out of our data. Okay, so I'm simply plotting all the data points. Let me just take the eraser and remove this guy. So I'm simply plotting all the data points that I have got from any of the websites that I've already invented. Now, if I look at this graph right away, I can see there is kind of correlation which is going on. We have already seen into Pearson's correlation coefficient. I can try and find out what is the correlation coefficient over here. I am sure the correlation is going to be strongly positive because clearly I can see there is a positive direction in which the correlation is going on. Okay, but that is not what I'm going to do in case of regression analysis. Regression analysis is where I'm going to simply draw a line. That's all I'm going to do when it comes to regression analysis. I'm going to draw a line simply. This is the only thing that I'm going to do. Okay, that's all. In regression analysis, this is the outcome, right? That's all I'm going to do. My objective is to draw this line, and this line is also known as best fit line, or it is also known as regression line. It is also, in a very layman's terminology, is known as a straight line. Now, why I say that it is a straight line? Because every straight line has a very simple equation. The equation of a straight line, which is covered by axis x and y, is given as y is equal to mx plus c. Right? Now we just need to know what is this m, what is this x, what is this c, and what is this y, and we should be able to formulate what is a regression analysis. So what is happening here is this y guy is actually whatever you see on the y-axis, obviously. What do you see on the y-axis? Something that you are trying to predict, or something that you are trying to infer, something that you are trying to approximate. In this case, what are you trying to approximate? The rent that I'm going to pay. So rent comes on the y-axis. So y becomes my target variable. This is something that I'm trying to approximate, or something that I'm trying to predict. Whatever I'm trying to predict, or whatever I'm trying to approximate, becomes my target variable. And whatever other variable which is trying to help me approximate this target is known as the predictor variable, or the independent variable. Okay, it is either known as a predictor variable or an independent variable. This target variable is also known as a dependent variable. Why? Because I can clearly see, and my mind tells me, irrespective of whether there is a causation or not, there is clearly a correlation. That is the reason why the rent, or the size of the house, is going to impact the rent of the house. Okay, or in the other words, the rent of the house will be dependent on how much is going to be the size of the house. Clearly, if I have a 2 BHK, the rent will be not equal to the one that I had to pay if I had a 4 BHK. So 4 BHK is going to have a larger rent as compared to 2 BHK. So this is how I'm trying to make an approximation. Right? That's the only thing that I'm going to do. That's why clearly this is basically a straight line that I have fit. So that's why it follows the equation of a straight line y equal to mx plus c, where x is the value you have on the x-axis, which is your predictor or the independent variable. Y is the target or the dependent variable. Then what is m and c? M is a factor which is always attached to x. They are best friends. You do whatever you want to do, you will never be able to make m equal to 1. Okay, you can never make m equal to 1, and you can never make c is equal to 0. If this is the case, what is going to happen with this line? If m is equal to 1 and c is equal to 0, then the value of y is equal to value of x, which means the line will now, let me change the color, the line will now look something like this. It will be a line which passes through the origin, right? Why should that be the case? Because if y is equal to x, then for x is equal to 1, y will be equal to 1. For x is equal to 2, y will be equal to 2. X is equal to 3, y is equal to 3, right? That is the reason why it will be a straight line passing through the origin point, or the 0 point. Okay, but that's really not going to be the case. Okay, in some cases it may well be. I mean, you don't know. If you look at this problem statement only from a very clear or very practical kind of a perspective, if you have a house with size in square feet equal to 0, it means you have no house. Do you have to pay a rent? The answer is yes. I don't have to pay any rent. Which means if the value of s is equal to 0, then my value of r is also equal to 0. Which means the straight line will pass through the origin. But that does not mean that both the values of m and c will be what I would like you to be. Okay, if the values of m is equal to 1 and the value of c is equal to 0, which we are going to define, there are names for m and c. If the values of m is equal to 1, c is equal to 0, then value of y is now becoming equal to value of x. That's why this is a straight line with this angle. Okay, if you remember basic geometry, this angle is 45 degree. This is a straight line. This part or area on this part is exactly the same as the area on this part. Okay, it is just the half line. It is clearly creating a mirror image of this part as compared to the other part of this graph. Okay, so this part P1 becomes a mirror image of this part P2. Hope I'm clear. Okay, let me just clear all the drawings and try and draw something else once more. So this is my Y and X. I have some points which I'm going to draw like this. Okay, I have some points which are like this. Okay, these are the values of size of the houses as plotted corresponding to the rent of the houses. And then I take a straight line, and this is what I would like to do. I would like to plot this straight line. Right, I would like to find what is the straight line. Okay, the straight line is known as the regression line or the best fit line. The straight line is known as the regression line, the best fit line. Simply, it is a straight line. And the formula of a straight line is y is equal to mx plus c, where y is the target or dependent variable, x is the predictor or independent variable. Okay, m and c have names as well. What is c? If you would like to solve this equation here, okay, what is going to be the value of c? C is going to be y minus m of x, right? If I want to do c equal to 0, right? If I assume that c is equal to 0, then y becomes, if c is equal to 0, then y becomes m of x, right? If c is equal to 1, then y becomes m of x plus 1. This means the straight line or its angle will be determined this by this value of c, right? Because this now can be closer to 45 degree provided I have m is equal to 1. If m is equal to 1, then y becomes equal to x, and then this angle over here becomes 45 degrees centigrade, right? So this line becomes a line that is clearly dividing this part 1 and part 2 of this x and y plot into two equal parts, right? That will seldom be the case. Okay, rare to rare, you will be very, very lucky, then only you will get a line like that. But there can be a line, so mathematically it is really possible. So the value of c determines how much slant this line will be on the upper side or on the lower side. That is the reason why I will again get back to my text. I don't know whether I can write it again over here. C, sorry, C is called the slope, okay, or also known as the intercept, and M is called the slope. Now, what is this concept of intercept? Intercept means if x is equal to 0, okay, and m is equal to 1, okay, then what happens? Y is equal to mx plus c, right? C is equal to what? C we don't know. X is equal to 0, then this part is 0, right? Irrespective of whatever the value is m. So I can clearly remove this. If x is equal to 0, then y is equal to 0 plus c, else I can say y is equal to c. So the value of y becomes c if x is equal to 0. So that is the starting point of this graph. That is why it is called the intercept, because that is the point on the y-axis, the point on the y-axis where this line is actually touching the y-axis. So let's say I have a line like this. In this case, the intercept is this. So this will be the value. Let's say this is y of j, right? This y of j becomes my intercept. Intercept is where my regression line or my best fit line or my straight line is simply cutting the y-axis where the value of x is equal to 0, right? And then m is known as the slope. Larger the value of m or smaller the value of m is actually going to determine how slant my graph is going to be, right? We are going to mathematically look into this, so don't worry. When we look into this in a more mathematical way, we will come to know. But as of now, this is the only math you need to know, is that I have the straight line which can be represented as y is equal to mx plus c. This is a regression problem where I'm trying to approximate the value of a continuous variable. The target variable for me is y, also known as the dependent variable. The x is my predictor or independent variable. I have a value called m in the equation, y is equal to mx plus c. I have m. M is the slope of this line, which is known as the regression or the best fit line, which I'm trying to find. This is my output. Okay, this is my expectation. And there is this value c, which is my intercept, right? These are the intercepts. Intercepts is where my best fit line cuts the y-axis when the value of x is equal to 0, right? Now, keeping this in mind, we are only here to find out the values of m and c. Why? Because you have already downloaded the rest of the values, right? As I shown you earlier, you have downloaded the size, you have downloaded the rent. Okay, there is a certain name which is given to this exercise that you are doing. Okay, but I am not going to take that name right now. I will give that name at a later stage. I don't want to confuse you. This exercise has a name. Okay, but that exercise or that statistical name is something will come at a later stage. But as of now, what you are doing, simply put, is you already have some data of something which has happened in the past. Example given, you have a size of 1000 square feet house which was given to a friend of yours for a rent of I don't know, 20,000 rupees. There was a flat of 800 square feet size which was given at a rent of 18,000 rupees. You already have this historical data. You have the x, you have the y. To fit this line or to get this line, you need to solve this equation. That's why you need to get the value of m and c. The moment you find the values of m and c, you are done. So that is your objective, right? That is the objective. If that is the objective, my null hypothesis is what? My null hypothesis is going to be, I just select this. My null hypothesis is going to be what? Let me just try to remove all these things. Okay. My null hypothesis here is going to be what? It is something that I don't want to prove, right? I have already seen null hypothesis is always something which I don't want to prove. Null hypothesis is always something which I don't want. The null hypothesis is what? Opposite of the alternate hypothesis. Alternate hypothesis is what? I can clearly tell you there is an increase in the rent when I increase the size of the house. If the size of the house is 0, I have to pay no rent because there exists no house. Hence, my regression line, I have assumed or I have proclaimed that it should pass through the origin, right, with an intercept of 0. So y becomes y is equal to m of x. I just need to figure out the value of m. And then in that equation, okay, in that equation which I had, y is equal to mx plus c, here c is equal to 0, and so y becomes mx. I just need to know the value of m, and I can put that value in the above equation, and I can get the value of y for any x, right? So for any x, let's say I have 5 x's already written. I have a house of 700 square feet, 750 square feet, 800 square feet, 850 square feet, and 900 square feet. Okay, I already have these values in place. Okay, 700 square feet rent, let's say that is 15,000. 750 is, let's say, 17,000. This one is 19,000. 850 is 21,000. And 900 square feet is, let's say, 23,000. I already have this data. Let's say I would like to predict, I have a house of size 950 square feet. What is going to be the rent? I'm just going to put the value of X here. I have already found out the value of M, right? I have approximated the value of M. I know the approx value of X or the actual value of X. I put this over here, I do a multiplication, I get the output Y, right? That's the objective here. But then I am not predicting, I am only inferring. Okay, so that's exactly what I am doing. I hope until this point in time it was clear, right? If that is clear, let's make a close now. We will be taking this example far more, and then we are going to work a lot on this. But I would like to just leave you with one point that I wanted to avoid as of now, but I just wanted to give that to you so that you can do some kind of reading on your own. This problem statement that we have looked into is also known as a supervised learning problem. Why is this called a supervised learning problem? Is because there is already access to previous or historical data containing, this word is very important, so I'll mark this into quotes, containing the actual outcome in those cases. Right? Example given, if you look at this, if you look at this part, for these 5 values that I have, these are historical values. I don't only have the X value, I also have the precise Y value. So I have access to historical data or previous data which contains the actual outcome in those cases. And that's why this is a supervised learning problem. At a later stage, are also going to look at problems where we only have this much data. We only have this much data. We only have the value of X. We don't know what is Y. It's a very peculiar kind of a problem statement. It is known as unsupervised learning problem. Let's not go in there right now, but as of now, you have the data. You have downloaded it from the rent websites, like you have downloaded it from 99acres, magicbricks.com, and you have this 5 data points over here where you already have the values of X as well as Y, what has happened in the past, right? So that's why this is known as a supervised learning problem. Okay, give me 1 minute. Okay, so this is what I wanted to leave with. So supervised learning problem is where you already have access to historical data, and there you already know the outcomes. Basis that you are fitting the regression line. You are fitting the regression line, and you are trying to find out, or you are trying to approximate, right? We said that we cannot infer, we cannot do the prediction here because this is a continuous variable. A continuous variable can take any value, minus infinity to plus infinity. We are trying to approximate what is going to be the value for any other given X, right? Let's leave it here. I would like you to look at this video once more if you have time, and then maybe you would like to look on the internet on what is actually regression. You can have some background information on what is regression and what is a supervised learning problem. But irrespective, even if you don't do that, it's not going to be a problem, because in the next session starting, let's say Monday, we are going to look into the regression problem in depth with some math. Okay, so we are going to define our hypothesis, we are going to define our math, and then we are going to try and solve the problem, and we are going to look into uh, uh, a problem which is within this problem only. If we solve that hidden problem, then we solve the major problem, right? I think we can make a close here. Let me just clear all the drawings. Let me stop this screen share. Thank you, Rohit. Good night.
Thank you.